Hello student. So in this lecture we are going to understand three type of laser scheme. Okay, three type of laser scheme: two level scheme, three level scheme, and four level scheme. Okay, let's see in details. Okay, two level scheme. Okay, even is your ground state, it is your excited state. Initially you using some pumping scheme. With that help of that pumping scheme, your electron goes to the excited state, and while coming out from excited state to the ground state, it emits energy, and that is stimulated emission is here, and that stimulated emission giving you to the laser. Okay, so there is only two steps is involved in two level scheme. One is the excitation and another is the de-excitation, and this kind of laser scheme is called as two level scheme. Okay, two level scheme. Only two energy levels are used for lasing. The atoms are pumped from E1 to the E2, and stimulated emission takes place from E2 to the E1. Okay, so thus energy levels used for pumping and stimulated emissions are same. Example is diode laser. So what is the drawback of this two level scheme? Same energy levels used for pumping and lasing. Since number of atoms E1 and E2 may be the same, population inversion would be the difficult to achieve, and hence lasing become difficult. So that is only the drawback of two level scheme. Three level scheme. As name suggests, this three level system, three step is involved. Okay, three step is involved, just like see here. E1 is our ground state, E3 is our ordinary excited state, and E2 is our metastable state. E2 is our metastable state. At initially, with the help of pumping, our electron goes to the excited state. At once it is stays here up to 10 to the power minus 8 second, it comes to this E2 state, which is our metastable state, and this is the radiation-less transition is happening here, where 10 to the power minus 3 second is quite large as compared to the 10 to the power minus 8 second. So it gets enough time to for the stimulated emission, and some external photon is encountered with the system to be here, and while coming out from E to the E1, it emits energy, and that is our laser light. That is our laser light. So three steps is involved here, therefore this stage is called as a three level scheme. Okay, another is the four levels system scheme is here. Initially the pumping transition is takes place, or with the help of pumping transition is takes place. E1 at the ground state directly go to the E4 state, while E4 to the E3 rapid decay happen and it comes to the E3 state, while E3 to the E2 state lasing action is takes place, or the it emits energy, and that is our laser, and again E2 is comes to the ground state, and therefore the four level system is involved here. Therefore this system is called as the four level laser. Okay, and the lasing and pumping takes place simultaneously here. This is the continuous wave laser. Four level laser scheme is the continuous laser scheme. Example of this four level laser scheme is the helium neon laser, Nd:YAG laser, and CO2 laser. Okay, so I hope that you are cleared about three level scheme. Okay, now we are going to understand the helium neon laser with the help of principal construction, working, and its application. Okay, if your question is asked in your exam, then just write a short notes on the helium neon laser. Then please make sure this thing that there are several points should be come in your answer, like principal construction, working, and application. So okay, so here are some points. It is low power continuous laser. It is gas type of laser. The energy levels are more precisely defined, and transition from higher to lower levels are sharper, and therefore electrical pumping is used here in the helium neon laser. Electric discharge using high tension power supply is used in the construction of helium neon laser. Okay, so just try to understand the constructions here. Okay, you just see here, this is actual case. Okay, this is actual case is here. Okay, can you see? And high tension power supply is applied between these two terminal. Okay, so here is the cathode terminal, and here is the anode terminal is there. Anode terminal is there. Okay, so just see the construction part. Glass tube of length 10 to 100 centimeter, or the diameter 2 to 8 millimeter diameter will be there, filled with the mixture of 80% helium and 50% neon gas. So the mixture is helium 80%, 85%, and neon is 50% is there. Active system is neon. Pumping system, helium is used for the pumping scheme. Okay, electrical pumping is used here. Pressure of helium is 1 millimeter of Hg. Pressure of neon is 0.1 millimeter of Hg. Electrode connected to the high tension power supply, like 10 kilovolt power supply is used here, 10 kilovolt, and produces electrical discharge. Okay, produce electrical discharge. Brewster's window is here. Brewster's window. Okay, at the ends of the active medium here, and silica windows were mixed at the end of two mirrors where, or Brewster's angle produces polarized light. Okay, this Brewster's angle produces polarized light. Okay, so at the end of two mirrors were fixed. Okay, produce polarized light. Two mirrors is fixed here, and you are getting laser light is through this mirror. Okay, one is fully reflecting mirror. This is fully reflecting mirror, and another is the partially reflecting. Okay, and separated with the distance of n into lambda by 2. Okay, so this was all about the construction. Now just see the working of helium neon laser. Okay, this figure shows the energy level diagrams of the helium and neon atoms. The energy levels E2 here and E3 are the metastable state of helium atom. Okay, and when the high tension power supply is made on here, when the high tension power supply is made on, in the previous construction part we have seen the high tension power supply we use, the electrons are released from the atoms, and these electrons are energized due to the potential difference across the cathode and anode terminal. Okay, so high tension power supply is there, that's mean high potential difference is there. The excited electrons collides with the helium and neon atoms. So these excited electrons collides with the helium and neon atom. Okay, and as the percentage of helium atoms is more as compared to the neon atoms, okay, and also helium atoms are lighter than the neon atoms, the helium atoms more readily excited than the neon atoms, and the electrons preferably excite helium atoms from the ground state E1 to E2 and E3 level. Okay, so this can be represented using this equation. Just see here, helium atom is encountered with the energized electron, and this energized electron excite the helium atom. Okay, so E2 and E3 level are the metastable state, as I told you, of the helium atom. Okay, so the excited helium atoms collide with the neon atoms. That is an interesting part. Okay, so the energy level E4 dash and E6 dash of neon atoms are close to the level of E2 and E3 of helium. Can you see the energy state of E4 dash and E6 dash? Okay, which is close to the E2 and E3 dash. Okay, and therefore this can be also represented by using this following equation. Just you can see here, helium atom, which is our excited H star, which encounter with the neon atom, and therefore it excited to the neon atom. It excited to the neon atom. Okay, so once it goes to the neon atom, okay, so while coming out from neon atom is also gets excited, and therefore the several transition is happen here. You can see here E6 dash to the E5 dash, and you are getting 33,900 angstrom light is here. You are getting from E4 E6 dash to the E3 dash. Okay, you are getting 6328 angstrom unit, and that is our laser light that we are interested. Again here you can see one transition is there, that is 1.15 micrometer wavelength will be get here. Spontaneous emission is happen here, and E2 dash is there, metastable state again, and E1 dash is the ground state is here. Okay, so several transition is happen here that you can see on the diagram. Okay, so in certain respect, okay, we simply say that once it's come to the here E2 dash, when the de-excitation of collision with the walls of the tubes is happen, and therefore it again come to the ground state, and this circle or this cycle continuously repeat itself, and we are getting ultimately a continuous laser input. Okay, so this was all about the working of helium neon laser. I hope that you are clear about the principal constructions and working of helium neon laser.